Law 2. The Law of Areas. An imaginary line from a planet to the sun will sweep over equal areas of the ellipse in equal intervals of time.
That's kind of a confusing statement. What it really means is that the planet moves faster in its orbit when it is closer to the sun. Kepler's law just explains things mathematically.
Here's a planet in its orbit. We've marked 3 different places on the orbit. Each little ray is how far the planet travels in 1 month. The rays are different lengths, which means the planet is traveling at a different speed at each of those little intervals. Why do we know that? Because speed is distance per period of time, and in this case, the amount of time is the same, but the distances traveled are different, so the planet moves at different speeds along its orbit.
What Kepler discovered is that for these equal intervals of time of 1 month, if you multiply the distance the planet travels on its orbit, or the length of the ray, by the planet's distance from the sun, you always come up with the same number.
Kepler discovered an inverse relationship between how far a planet is from the sun and how fast a planet is traveling. So, as a planet's distance from the sun gets smaller, its speed gets bigger, and vice versa. So Kepler was basically saying that planets move faster when they're closer to the sun and slower when they're farther away from the sun. If a planet went in a circular orbit, the planet would always be the same distance from the sun and would always travel at the same speed. In an ellipse, though, the planet's distance from the sun varies, and Kepler figured, so does its speed.
Just remember Kepler's second law in terms of this. A planet moves faster in its orbit when it's closer to the sun. When the planet is farther from the sun, it moves more slowly.